Okay, in this video, we want to take a closer look at compound inequalities because we didn't throw any of the more confusing ones at you. And the way we're going to take a closer look at this, let's read the statement. It says, we previously learned that compound inequalities are two inequalities joined by or and. Sometimes you really need to think about what the inequalities are saying before you determine the solution. Look at this example. A sign at the ticket booth reads, guests that are under 3 and over 62 get in free. Does this make sense? If not, why? How would you change it? So let's discuss this a little bit. It says guest under 3 and over 62. Now, I told you in the previous videos that the word and means both. So in order to get in free, you must be under 3 years old, and also you have to be over 62 years old. So obviously that does not make sense. So again, no, you cannot be under 3 years old and over 62 at the same time. So that's the reason it doesn't make sense. Now, how would we change it? And we could very easily change this to where instead of the word and, we should have used the word or, because actually either statement, if you're under 3 years old or if you're over 62 years old, then you're going to get free admission. So that's how we could change it. We could just put change and to or, and that would have actually fixed the problem. So let's look at some of these solutions and see if we understand why maybe they don't make sense. So it says on number 1 that we want x. X can be any value below -3, but it also has to be bigger than 7. Well, let's take a look at that. The numbers that are less than -3 are these numbers. The x values must also be bigger than 7. Now, question, how can a number be smaller than -3 and also bigger than 7? That goes back to it's just like this statement up here. It can't be both. It can't be -3 or smaller than -3 and bigger than 7, so there would be no solutions there. So be careful with some of these because sometimes you might run up on some to where that can't be true. Here, A has to be greater than or equal to 0. Since it's an and, that means that both have to be true. A has to be bigger than 0. So I'm just going to put an arrow here. Must be bigger than 0, and it also must be smaller than 6. So that'd be less than 6. Now that's doable. Bigger than 0, smaller than 6 means it's between 0 and 6. So that'd be all values from 0 to 6, including 0, not including 6. So that is a doable statement. Okay, number 3. Again, it's an and statement, so both must be true. We're looking for values that are less than or equal to 5. So let's find 5. It's right here. So less than or equal to 5. So that'd be any of these values. But it also has to be less than or equal to 8. Now let me use a different color here. So let me finish drawing this. So we're looking for values smaller than 5, but they also have to be smaller than 8. We didn't run into any that went in the same direction like this. So let's think about the word both. We're looking for numbers that are both smaller than 5 and smaller than 8. Now let's change to a third color. And let's ask you, is this number right here smaller than 5 and smaller than 8? No. It's smaller than 8. It satisfies the red condition, but not the blue condition. Is this number smaller than both? No. Is this number less than or equal to both? Yes. It is on the blue line, and it's also covered by the red line. That satisfies it. 4 satisfies both. 3 satisfies both. So which number satisfies both? The numbers from here to here. The purple numbers. All values from -infinity up to 5. So we could have pretty much said, okay, if k has to be smaller than 5 and it also has to be smaller than 8, well, that's just going to be the numbers that's smaller than 5. And we can do away with the second part of that. Number 4, m has to be greater than -4. So m has to be one of these numbers, but it also must be greater than or equal to 2. So think of it like this. It must be both. Which numbers are covered by both lines, are covered by both colors? That would be the numbers from here on. So pretty much if this is your statement, your solution would be all the numbers here, and this rest of it doesn't even matter anymore. That'd be all the numbers from 2 to infinity, including 2. Number 5, r is less than 8. Okay, now we're dealing with an or statement. R can be any value smaller than -8, or R can be any value bigger than 1. Now that looks just like they did before. That's fine. That'd be any value from -infinity up to -8, or any value from 1 to infinity. That's what we did on the previous lesson. Let's do another or statement. Y can be any value greater than or equal to -2, so that'd be any of these values, or R can be any value bigger than 7. Well, we've already colored those. So R can be any of these numbers or any of these numbers. So therefore, R can be any of these numbers. It's kind of like you have a bunch of duplicates there. You're saying R can be any of these numbers. Now let's also throw these numbers into the pile. Well, they were already in the pile. So R can be any of these numbers since it's an or statement. So that would be all numbers from -2 to infinity. We included -2, never include infinity. Number 7, n can be anything, and again, there's an or statement, so either one is acceptable. N can be any value less than 3. So n can be any of these numbers, or n can be any values less than -9. Well, we've already included those. So this is going to include all the numbers. This is just the same numbers duplicated. So that'd be any value from -infinity up to 3. And that would be, let's try that again. There we go. And number 8, b can be any value greater than -1. So that'd be any value from here over, or b can be any value smaller than +1. That'd be any value from here to the left. B can be any of these numbers, or b can be any of these numbers. Wait a minute, that's every number. That'd be all real numbers. So all reals, or every value from -infinity up to +infinity is included there. When you put all those numbers together, you have actually included every number. Now the next ones we're doing the exact same thing, except for they're giving us an inequality to solve first. So number 9, step number 1, let's solve the two inequalities. Get rid of -4, we're going to add 4, so you get x is greater than 3, or divide by -8, make sure you flip your symbol over. That'd be x is greater than -6. So x can be any value greater than 3. This is an or statement, so either set of x's is included in the final solution. X can be any value greater than 3, or x can be any value greater than -6. Well, the values greater than -6 actually include as well the values greater than 3. So if we could actually take away all these values that were greater than 3 and just say that x is all these values, and it's going to include these values are included in those values. So pretty much we can use that as a solution. My answer is going to be any value from -6 to infinity. Solve number 10. Solve first off for p. We're going to multiply by 8, and it gives you p is less than or equal to -8. This is an and statement, so a reminder that both must be true. So p has to be less than -8, and also when you move your 9 over, you get p is greater than 6. So p has to be smaller than -8, and p has to be bigger than 6. Wait a minute. Smaller than -8, but it also has to be bigger than 6. Which numbers are smaller than -8 and also bigger than 6? There are none. That's no solution. There's no overlap. If you have an and statement, again, you're looking for overlap. You're looking for both. Subtract 7 to isolate r on number 11. So you get r is less than 3. And move the 1 over, it gives you -2r is greater than or equal to -2. Divide by -2, make sure you flip your symbol over. So r must be smaller than 3, and it's also got to be less than 1. So which values are both? We're looking for overlap. We're looking for the numbers that are smaller than 3. Let's find 3. So the numbers that are smaller than 3, but they also have to be smaller or equal to 1. Where does the overlap occur? The overlap occurs from here to the left. So what is my answer going to be? My answer is going to be all values from here to the left, which is pretty much these values. Every value from negative infinity up to 1. That should be a positive 1. And that's it. Number 12, step number 1, get rid of the negative 2 by multiplying. Make sure you flip. We're going to add 4 now, and you get a is less than or equal to 2. Or move the 1 over, you get a is greater than or equal to 7. So since it's an or statement, we're going to include all answers. We're going to put this as part of our answers. This is also part of our answers. So any number that is smaller than 2 is in our answers. So here's 2. So we're going to take all of these numbers. We're going to combine it with all of these numbers that are larger than 7. And that looks like our classic OR problem. So that'd be all values from negative infinity up to 2, including 2, or any value from 7 to infinity. So that's like our old problems. Number 13. Move the 3 by subtracting gives you 5k is greater than 5. Divide by 5 gives you k is greater than 1. And, so both have to be true. Subtract 8 gives you 9k is greater than or equal to negative 81. Divide by 9 gives you k is greater than or equal to negative 9. So k has to be bigger than 1 and bigger than negative 9. Which numbers are both bigger than 1 and bigger than negative 9? Let's take a look at it. Here's all the numbers that are bigger than negative 9. But your values also have to be bigger than 1. So greater than 1 would be these values. So which numbers are both bigger than negative 9 and also bigger than 1? That would be these values. So that'd be all the values from 1 to infinity. Now let's talk about the number 1, just to be certain. Is the number 1 included? Since it's an and statement, it must be a member of both sets. Is 1 bigger than negative 9? Yes. Is 1 bigger than 1? No. So therefore, since 1 is not a member of both sets, we will not include 1 in our final answer. Number 14, step number 1, move the 1 by subtracting. You get negative 2y is greater than or equal to negative 18. Divide by negative 2. Make sure you flip your symbol. Move the minus 5 by adding, so it gives you 5y is less than or equal to negative 45. Divide by 5 gives you y is less than or equal to negative 9. So since it's an OR, we're going to include every one of these numbers in our answers. All numbers that are less than 9, which would be all of these numbers, in addition to every number less than negative 9. Well, I think we've already counted those. So all the numbers less than negative 9 would be inside of this. So all of these numbers are actually included in these numbers. So therefore, as a final answer, we can just say, well, that's just all the numbers less than or equal to 9. So it'd be all the numbers from negative infinity up to 9, including 9. Okay, number 15. Subtract 6 gives you 2x is greater than negative 10. Divide by 2 gives you x is greater than negative 5. Or subtract 5 gives you 9x is less than or equal to 36, so therefore x is less than or equal to 4. So therefore, since it's an OR statement, these are our answers, or these could be our answers as well. So x can be any value bigger than negative 5, which would be any of these numbers. So x can be any of these numbers, or x can also be any of these numbers smaller than 4. So since we included these numbers in addition to these numbers, that would be all real numbers because every number got included in one set or the other. So that'd be all values from negative infinity to positive infinity, every number. Number 16, subtract 4 gives you 40. Divide by 10 gives you v is less than 4. And so both must be true. Subtract 6 and divide by 3. So v has to be less than 4 but it also has to be bigger than negative 7. So less than 4 looks like this. So these numbers are less than 4. Bigger than negative 7 would be these numbers, so that's legal. The numbers that are less than 4 but bigger than negative 7 are the ones in the middle. That'd be all the values from negative 7 up to 4, non-inclusive. So that's like an old problem. Okay, a couple more. Number 17, we're going to subtract 1, gives me 10n is greater than or equal to negative 60, divided by 10, n is greater than or equal to negative 6. Or add 10 gives you negative 9n is less than 36. Divide by negative 9, make sure you flip, that'd be a negative 4 then. So n can be any number bigger than negative 6. So n can be any of these numbers, or n can be any of these numbers here. Well, we've already said those numbers. So pretty much putting the two groups together would just be any number bigger than negative 6 or any number from negative 6 to infinity, including negative 6. And then 18. We're going to add 4 to get rid of this. That'd be greater than or equal to negative 12. Divide by 6 gives you k is greater than or equal to negative 2. And subtracting 2 gives you k also has to be less than or equal to negative 7. So k has to be both. We're looking for a number that is bigger than negative 2. Okay, here is negative 2. So the number has to be bigger than negative 2, and the numbers also have to be smaller than negative 7. How can you be bigger than negative 2 and smaller than negative 7 at the same time? You can't. So therefore, that'd be a no solution.